I would like to invite the second speaker, and we have Mr. Won-Seok from Nestfield, and he's going to tell us about his pilot project in Korea, which is, of course, based on AAS. Good morning, good evening. I am Won-Seok, who is the R&D head of the Nestfield. Today, I'm going to tell you about AAS-based pilot project, which is conducted in South Korea. This project has been conducted for a long time, and we have been collaborating with various experts and various entities. Thank you very much for your collaboration, and thank you very much for your support and help. Thank you. I personally is a software developer, and in this project, I've been in charge of the solution design and solution development. So today, maybe I'm going to tell you more about some technical stuff, like what kind of a solution has been implemented. But it's not going to be a technical deep dive. I'm just telling you why these kind of activities are really necessary and what is the implication of these kind of activities. Lots of things are going on right now in Korea. Today, I'm going to introduce the AAS related technologies and some of the key implications that can have direct impact on the AAS. As you can see on the table of contents, I have the 4 bullet points. The first one is the AAS reference model, how we develop the reference model. The second one is really important part of the AAS development roadmap. And you may heard about the API and repository. I'm going to tell you more about the API and repository development. When we were working on the project, we developed some of the solutions. I'm going to tell you how these have been applied to the system and how AAS has been incorporated into those technologies. Based on these 3 components, I will show you. Actually, we have 2 machines are co-working together, and we have the collaborative testbed right now. I'm going to briefly introduce you how we have built that testbed and how the testbed has been working. Let me begin. First, AAS reference model. The objective of developing a reference model is to make AAS widely available in South Korea and easily available in South Korea. In the first round of project, we used the AAS technology to collect the data from the shop floor. And we applied that and we validated that. However, when we want to deploy that to the Korean shop floors, many people are kind of worried about the development of AAS. So they are a bit hesitant about applying AAS to their shop floors and the factories. So what we wanted to focus on is to make a reference model that can be widely used for the widely available machines in South Korea and widely available processes in South Korea. So in the second round of the project, what we focused on was developing various reference models. And the target systems are the motion device system, the 6-axis articulated robot, AGV, CNC machine, injection machine, and those were the target devices we worked on. And we created AAS model for these devices. As for the welding and the EV battery pack, we are currently working on the modeling right now. From each of the domain, there are better experts than I am, and they bring up the flagship devices, and they gave us a navigation guideline so that we can help a commonly and widely available reference model for the widely accepted devices. For us, the robot reference model was a bit special because this is the first model we ever created. We went through various steps, and the model has been quite advanced because we were going through a long enhancement process. We have the robot reference model for the 6-axis. You can see there are 473 properties. You can simply refer to the table. Not just the status information you can check out on the shop floor, but recognition information and some technical informations are also within that model. We refer to lots of documents. We did not create that from the scratch. And OPC UA companion specification, E-class, and the PI 4.0, they have produced some documentations, especially for the submodel specifications. Also, we refer to some of the commercial data sheets available in the market. And based on that, we recreated a reference model that can be commonly used in South Korea. We made a model and we invited the experts from each of the domain and each of the standards. We validated it and enhanced the model once again, and we opened the model to Germany so that it can be reviewed by our German counterparts. To make the model, we were going through some processes, and we have some of the other materials which can back up the process, and we have opened those materials as well, so you can have access to those information, how we develop that. And currently, we are working on various models, not just a robot, but we are currently developing many reference models. A AAS reference model needs to be verified if that can be really feasible option in South Korean factory. And there is a collaborative robot manufactured by the company Neuromecha. The model name is Indy 7. AAS reference model was applied to this robot, and we have worked on the verification. This robot is supporting the OPC UA, and even without OPC UA, we used other protocols. So we worked 2 times, one with the OPC UA and one without OPC UA. We used AAS and we were able to collect the data. The collected data on the cloud was analyzed, and we used the 3D dashboard that you can see on the screen on a real-time basis. This is really meaningful because the reference model can be used for the commercial products, and we were able to collect the data. Now let me tell you about REST API and AAS repository. In the PI 4.0 specification, yes, they have many documentation. They talk about information exchange via API. You can see the title of that documentation. The key point is written on the right side. You can see the diagram at the bottom of the right side. This is showing how AAS will be developed. This is a kind of the roadmap. The first step is the file exchange. This is what we did in last year. AAS is more like a representation of the property of assets. And the representation can be done via file. And if we make that representation as a file, the file can be exchanged. And the third step is among the AAS, they can mutually share the data and they can have autonomous interaction. That is the ultimate goal we have. The second step is API. To make the autonomous communication, AAS should be connected to other external devices or external AAS. So we need to have the outbound communication. To enable that outbound communication, we can utilize API, and repository can be the source of the data to send some of the data. We have utilized the REST API, and also we build our repository. Now the service is online. We are currently using that. Also, we have the web-based package browser, and the package browser can be the key UI that you can use this kind of service. This is the internal process. This looks kind of busy, but there is an asset, and you identify the asset. You got the asset ID. Based on that, you bring the AAS information, and within the AAS, there is a submodels, and within the submodel, you can see the more granular contents. And all this can be done on the web. And this is the API standard. And this kind of API can be supported with the repository. And you can see how the AAS information can be stored in our repository. And we have the web application called the package browser. And you can see how they are expressed or presented on our UI. Of course, REST API technology is in the middle. And I would say this is one of the most important technologies to make AAS more autonomous. I believe API can be the key foundation. And we can have the web version of the deployment of the AAS via API. Then the security can be the key issue. There can be some cases anybody can take any information that can be problematic. To relieve the concern, in Germany, they are using OpenID Connect. It's a kind of the access control. And as you can see here on the picture, when you want to have the AAS access via web server, ID and password, your credential needs to be verified, and there will be the authorization token. And based on the authorization token, you can get the information from the AAS, and your role-based access can be managed. Just like you are using the Google ID. When you have the Google ID, it's more like a single sign-on. This is more like a single sign-on. And we have the access level authentication information. For each of the property, the authorization management needs to be developed in the future. So authentication is available and authorization needs to be further developed, and the privilege management needs to be further developed. So far, I'm telling you about the AAS reference model, and they are really important in the development of AAS in Korea. To make it more interactive and autonomous, AAS repository and API are the key components. And during the project, we focused on the implementation of the repository and API. And many other technologies were updated. There are some technologies not directly related to AAS. For example, API specification. But today, what I'm going to tell you is this one. This one is directly related to AAS. I'm covering only the updates directly relevant to AAS. This is the 3D image view, and you can have the view on the 3D image. This is a new update. On the Package Explorer, this can be supported. And actually, this has been covered by the demonstration from the German side. AAS is not bringing the shop floor information, but design, engineering, and technical data can be brought via AAS. So the design-related information can be reviewed and validated. So that kind of functionality is really necessary. So on the package browser, this kind of 3D image file can be viewed. This is the new feature we added. The most widely used file format is the STL. So currently we are supporting the STL file format. As you can see on the picture, this is the package browser we have, and on the right side you can see the 3D image. For those of you who do not know about the package browser we developed, there was a package explorer to make an input onto AAS that has been developed by LNI 4.0, and that software has been further enhanced. It can be run on your PC, and you can use the AAS. However, in our solution, we have similar feature. Even though we are not putting input with our browser, but we can hold the information and we can see the information. That is the web-based package browser. The UI is pretty much the same as the Explorer we had before to make it easier to use. So I would say this is the web-based package explorer. Another one is mechanical breakdown. Actually, that was covered by the German side. And within the AAS, the feature is available. When there is a single asset, you know there are some sub-assets. In that case, mechanical breakdown can be used. And you can move around among the various assets. As you can see, on the robot arm, there are some parts. And when we make an asset modeling for that, when you are looking into the robot, but when you click on that specific asset, the joint asset can be popped up and you can see more detailed information. This kind of dynamic UI will be available to you. Of course, we are using API and we can bring the asset information from the repository. When you use this kind of mechanical breakdown, you can see and you can have a really granular modeling, especially for the part which has various subcomponents. The third one is you can see the data on a real-time basis. I mean the shop floor data. In the package browser, you created another UI to check out the shop floor information. That is how it was working. And now on the browser, you can see the data directly. You don't have to toggle around and you can see this kind of data and you can see the flow of the data, whether there is any abnormality or not. When you are using this kind of solution on the shop floor, this can be a really convenient one to the operators. The next one is data execution or the decision execution. Decision execution is on the cloud, you can utilize the data. Once the decision is made based on the cloud data, you should be able to apply that to the shop floor. In the first phase project, we were able to collect the AAS data. That's how our solution was built. And as you heard, and in various cloud environment, we can utilize various analyzing solutions, and we can utilize those data. And after that, we can make a decision. We can make configuration change and parameter change, and those changes should be updated to the field. To make that happen, we have the execution feature. Now, if we collect the data from the shop floor and once it is analyzed, it can be fed back to the field and to the field devices. I told you about the three key features and I told you about various updates. Using all of them, we have now two equipments and we have the testbed where two equipments are collaborating together. And you can see two machines and they have their own AAS. Two of them can be connected and we created a single testbed. Now let's imagine how the life has become more convenient. We have injection machine and we have the robot. I told you about the reference model because we created the reference model for the injection machine and the 6-axis robot. We have a company called Ujin Prime and they have the TE110. This is the injection machine. And I told you about the Indy 7. This is the 6-axis AAS robot. When we are combining these two assets by utilizing AAS, and we wanted to see what will happen. You can see the photo taken from the shop floor. The testbed is located in Ujin Prime, located in Poeun area in South Korea. And you can see their R&D center. And within their R&D center, we have located our testbed. And we have the injection model and the robot arm. They are working together. This is the operation scenario. The injection machine is making a product. A small object or product will be made. Once the product is made, the robot will pick up the product and it's going to be put onto the robot stack. And robot will pick up the product and move it to the scale. It's going to be weighed to determine whether it is pass or fail. Based on the information, the robot picks up the product once again and put it into the either pass or fail boxes. This is the configuration. Through the edge onto the cloud, the information will be stored. And we have the application that can exchange the information between these two machines. Data exchange is really necessary to share the information. As I told you, we made a data exchange mechanism between the two. If AAS can share the data together, it's going to be really great. However, that's going to be the future, something that we need to do. This is the scenario. Capability check means how capable this machine is. This has not been implemented yet, But this is going to be really important. That's why I want to tell you about capability check. Before making the integration between the two, you need to check out whether the other side of the machine can actually do the behavior that it is expected to do or you expect it to do. Then you identify the asset, whether the asset is the right asset you were looking for. After that, you validate whether the mold is installed in the injection machine and whether the right mold is installed on the injection machine. And after that, there must be some matrix for the pass and fail. And that kind of configuration needs to be delivered to the robot AAS. Whenever the product is changed, the new matrix will be given to the robot so that the robot can know whether the new product is fail or pass. And we can use the robot data and engineering data. And after that, we start our operation. Let me play a video clip. You can see the product, right injected, and status should be shared so that there will not be any collision between the two machines. Robot is picking up the product and put that onto the scale. And the robot already knows what is the matrix for the fail and pass. It makes the decision and put it into the right box, either fail or pass. Those two machines are working independently. The data exchange is done via the external application. Another video clip. In the case of emergency, the emergency information is shared between the two. Now you can see when the injection machine is stopped, the robot is stopped. This kind of integration was made. And we were able to see the collected data on the cloud, and 3D visualization was also possible. The biggest benefit is you only need AAS. AAS has all the data, and AAS can help you share and exchange the data. Of course, it is not autonomous yet. Anyway, the AAS can share the data, then we can think about various applications for the future. As I told you, in the future, when AAS can autonomously share the information and interact among themselves, that's going to be really great. That is something that we are pursuing after. And we are currently collaborating with the IDTA. And we are pretty much focused on the AAS autonomous interaction among them. And now we have an AAS network. This is an international project. There are lots of test beds. And in Korea, we have some of the test beds. Those test beds can be connected together and we can create a better scenario. This is a longer-term project. We are currently collaborating more with our German counterpart. Thank you very much for listening.